In today's video, you'll be learning about why the arc length formula works. So, just as a recap, the arc length formula is basically the integral from a to b of the square root of 1 plus dy over dx squared times dx. Alright? And another formula that'll be helpful for explaining the arc length formula is the distance formula. Right? And distance formula is basically square root of dx plus dy squared. And you might be wondering, why am I not using x and y here? Well, that's because for the arc length formula, you're actually, instead of adding like these big values of x and y, instead you're going to be adding minute values of such as dx and dy, so that you can actually find an accurate arc length. When what that means is that, let's imagine that you had this graph here, right? You had let me draw a better one, of this, okay? And basically, at this point right here, okay? Right here, at this point, if you can see it clearly, let's imagine that it had a bit of distance, but it's very minute. And as a result, it would have a very small x direction in magnitude and a very small dy direction in magnitude. Meaning its length would be, if you can see it, dy here. So sorry, dl here. Its length would be dl. And dl again is a very, very small distance. Okay? So, let me extend this graph here. So basically what you're doing in the arc length formula is that the integral, it adds up all these small dl values from the wanted boundaries. So let's say this is a to b here. So from a to b, it's going to be adding these very, very small, as you can see as I'm drawing them here, these very, very small lengths. And as a result, you will get the arc length from a to b here. Okay? Now, to actually prove the arc length, we're going to be needing the distance formula again. So, let me give myself some space here. So, right, we can write this as the square root of dx squared plus dy squared over dx squared times the square root of dx squared. Now you might be wondering, why is this the same expression as this one right here? Well, that's because the dx's right here, they actually cancel out because it's basically the square root of dx squared over the square root of dx squared, which is just equal to 1, so it doesn't matter that I put them there. So this right here would be equal to the square root of 1, because the dx squareds cancel out, plus dy squared over dx squared times, well, the square root of dx squared is just going to be dx. Okay? And now this can be written as 1 plus dy over dx and all that squared. Now, as you can see here, this is just what was inside the integral for the arc length formula. And basically, we're going to be adding this value here, right? And in order to get the sums of those magnitudes, dx and dy create, those very small magnitudes they create, we're going to be adding them up, and dy, alright? So, the reason we can take the integral of this is because we have transformed the formula so that dx is at the end. Okay, and the dx implies that we are adding up very, very small magnitudes, whether that be area or arc length. So we get the integral from a to b of 1 plus dy over dx squared dx. And this is our formula. So I hope that video helped. I hope this video helped, and I'll see you in the next one.